All right, let's get started. So you might be wondering, what is a differential equation? And by the way, all the cool kids would call these diff-EQ or DE. So a differential equation is basically an equation that involves a derivative of an unknown function and possibly the function itself. So here are some examples of some diff-EQs. This first one, this one right here, the y prime equals sine of x. This is something that we know how to solve. This is saying that there is some function whose derivative is sine of x. And the challenge would be to find, well, what is that function whose derivative is sine of x? And now this function is pretty crazy. You're saying the second derivative of some function plus the original function to the third power plus x is equal to 0. And the challenge would be to find what is that original function. Something down here, the second derivative of some function plus 2 times the first derivative of some function is equal to 3 times the original function. You need to be trying to find the original function. Over here, the first derivative to the fourth power minus some function squared plus 2 times x times the function minus x squared is equal to 0, and you'd be trying to find out what is that function y. So when you find the solution to a differential equation, it's often going to be a function or it could be a class of functions. So in the simplest cases, you can solve diff-EQs by just doing direct integration. So like I said, the y prime of sine of x, that means that y would be negative cosine of x plus c. Here, if you're given the second derivative of some function, just do the antiderivative. You have your constant of integration here. And then here I introduced a new constant of integration because these are not necessarily going to be the same constant. The steps, if you want to write this down, I'll pause here. The steps for solving a differential equation would be to separate, then integrate, then isolate. So this first one I'm just going to demonstrate. You don't need to write this down. You just watch. Now this is actually something that we can find the antiderivative of 2x without having to do the technique I'm about to go through. So the technique we're going to do is to separate, then integrate, then isolate. So to separate, we notice I'm using the dy dx notation. And I want to separate and put everything with a y on one side and everything with an x on the other side. So I'll just multiply both sides by the dx. So dy equals 2x dx. Then I'm going to integrate both sides. And over here you're thinking, well, the integral of a dy, there's nothing there. Well, you can put a 1 there, right? Let's look over on the right-hand side first because that's easier. What's the antiderivative of 2x? You already said it. X squared plus c. And over here, we're talking about the antiderivative of 1 with respect to y. Now, you might think, well, why don't we just do y plus c? Like every time we do an antiderivative, we add this plus c, some constant of integration. You only have to add some constant of integration to one side of the equation. First of all, it's a little confusing if you put a plus c on both sides because you might think that you're adding the same constant to both sides, but you're not necessarily. So if you were adding like a plus 2 on the one side and a plus 7 on the other side, well, why not just add like a plus 5 on the other side? So we won't add the constant of integration to both sides. We will just add it to the side with the x because we're ultimately trying to isolate the y, which this y is already isolated, so we're done. Okay, so the first thing I'm going to do is I'm going to change my notation from y prime to dy dx. And now I want to separate, so I want all my x's on one side, all my y's on the other side. Yeah, so it's sort of like cross multiplication. So on the left-hand side, I'm going to have y dy, on the right-hand side, x squared dx. Okay, so that was my separate. Now I'm going to integrate. So if you want to take a different color, if you want to write a whole new step, you want to integrate both sides. So what's the antiderivative of y dy? Yeah, y squared over 2. And then we're not going to do the plus c on that side. We're going to do it on the other side. What's the antiderivative of x squared over 3 plus c? All right, now we need to isolate. So we did the separate, we did the integrate, let's do the isolate. Now I'm going to do something a little crazy. I'm going to actually call this plus k. Are you uncomfortable? So here's the thing. When you're doing these separable differential equations, and you've multiplied everything by 2, so you have some arbitrary constant that you've multiplied by 2, well, 2 times some arbitrary constant is just going to be some other arbitrary constant. So what some teachers would do is, and in some textbooks, if you look online for resources, they might just go ahead and call that another just plus c. And then students get really uncomfortable because now you're saying like 2c is equal to c. Like, but 2c can't be equal to c. So what I used to do is I would say, well, if you want, call that c sub 1, if you like. So to represent it as a different arbitrary constant. This year I've decided to go a little crazy and call it k. All right, so that's equal to y squared, and then finally to isolate the y, square root, and we have to remember to do plus or minus. People often do. And so that's it. We've isolated the y, we're done. Before we get to the next one, I think I put some of this in your delta math that you had with the sub. Remember this rule? Multiply the base as you add the exponents. So if you had like a to the 4th times a to the 9th, that would be what? A to the 13th. A to the 13th. If I had a to the 4th times a to the x, a to the 4 plus x. I could go backwards too, couldn't I?
Sure can.
X to the 7 plus y could be written as times x to the y. E to the 7 plus y. All right, so that's going to come into play in this next example here. I'll give you a chance to write it down. I'll walk you through it. We, again, want to separate. So we want x's on one side, y's on the other. So dy over y equals 2x dx. Now, I'm going to pull that y off to the side and call that 1 over y dy equals 2x dx. And we're going to integrate both sides. What's the antiderivative of 1 over y? ln of y. What's the antiderivative of 2x? X squared plus c. Now we need to isolate the y. Remember, this is ln of y. This is not a product. So this is saying is like f of x, right? So do you remember how to solve a natural log equation? Swirl. So what's the base on that natural log? E. So remember, you want to do that base raised to that power, that whole thing, is set equal to y. So e to the x squared plus c equals y. We're not done, because I'm not going to leave this constant integration in the exponent. So let's split up this expression from what I was saying back up here. So I can call that e to the x squared times e to the c. Wade, you watching?
It seems even more complicated.
Well, e to the c, e is a constant, c is some arbitrary constant. So e raised to some arbitrary constant, isn't that just going to be another arbitrary constant? So this is really e to the x squared times k, or sometimes we'll put that in the front, k times e to the x squared.
So is k just any weird value of c?
K is just another arbitrary constant. All right, so here's number 3. You can go ahead and do your separate and integrate, but don't isolate yet. Okay, I'm going to catch up. So we did the separate. Then integrate. All right, and then you stop, yes? This is where I want you to stop.
Yeah.
Okay, so we want to use the information about y of -3 is equal to 6 to solve for c to find what would be called the particular solution. Okay? Now, when we did this before, when we were finding particular solutions with derivatives, we would go ahead and isolate the whole thing and then solve for c. But what we're going to do here is solve for c when you see it. Okay, it'll just make it easier. You can go ahead and isolate the y and then plug in to solve for c, but it's just easier if you solve for c when you see it. So plug in the 6 for the y and the -3 for the x and solve for c. 12. Okay, now go back to this equation, plug in the 12, and then isolate the y. Now, normally when I take a square root, I would do plus or minus. However, and you're going to see this on delta math, where you're going to be confused on why you're getting it marked wrong. If you plug a value into the function and you get a positive result, then it has to be a positive square root, right? If you had a negative out here, and whatever number you plug in for x, you're going to end up with a negative result. But we ended up with a positive result that they gave us. So that means that this has to be a positive square root. So that's our final answer there. So when you're doing this on Delta Math, and you're going to get more than one attempt, if you get it wrong on the first attempt, check that part of it that you're doing, that it's maybe not a negative square root or a positive square root. So for example, if you were told that y of negative 3 is equal to negative 6, then your answer would be a negative square root of blah, 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 blah. Okay? All right, let's do another one. Try this one all on your own. So when you plug in, you're going to have 0 cubed over 3 equals negative 1 minus negative 1 cubed over 3 plus c.
It's 2/3, negative 2/3.
Yeah, that's a negative 1, and then negative 1 cubed is negative 1 times that negative 1 makes that a positive 1/3 plus c. So that's negative 2/3 plus c is equal to 0, so 2/3 is equal to c. And so now go back and isolate the y. Now, since you're doing an odd root, you don't have to worry about a plus or minus concern. It's just the cube root. All right, I want to show you how I start this one, so don't get too far. So the advice I have is that you'll notice that you don't have an x. So if you might be tempted to move the 3 and the y to the other side, and I find it easier to only move the y. You can move the 3 over, but then you have to deal with the 3 in the denominator. So I would recommend that you just do dy over y equals 3 dx. All right, and then you integrate. It's natural log of y equals 3x plus c. And remember, we want to solve for c when we see it. So I'm going to plug in the 7 for the y and the 0 for the x.
I got it. That's good. K, E, 2, 3, X, 0.
There's no k in the answer.
I got it right.
Okay, so are we there with the natural log of 7 equals c?
No, I forgot to do that part. I just got the... Yes.
So natural log of 7 is some decimal, but I'm just going to leave it as natural log of 7. So now I'll plug that back in. So natural log of y equals 3x plus natural log of 7. And we want to isolate the y, so what do?
Swirl.
Swirl. So we're going to do e to the power of
3x plus ln7.
Equals
Y.
y. We're not done.
Separated.
Yeah, so we're going to call that e to the
3x times e to the ln7.
times e to the ln of 7 equals y. E to the ln of 7, what's that? 7. So you really have e to the 3x times 7 equals y, or 7e to the 3x is equal to y.